listening to Emma equals MC squared, a podcast where I can help you learn or review about science in a fun and fast way too. Please leave a comment or review in the comment section below so I can help others learn about science in a good way. I'd like to keep these as ad-free as possible, so please support me by checking out my store link in bio, where I sell lots of fun posters and products, and some of them do, in fact, relate to the podcast. Now, to the episode. Hello, and this is the first episode out of, 5, I think, at least, that is going to be talking about radiation. This is just the introduction to get you to know a little bit about radiation. Now let's start with the isotopes that are not radioactive. These are the elements up to number 19 that have a stable nuclei. Then after that we get to a mixture of unstable and stable. These are from numbers 20 to 83 on the periodic table. Whenever there is an unstable nuclei, it means it's radioactive. This means that it'll spontaneously emit energy to become more stable, and the energy is called radiation. Think of it like a toddler with a bunch of energy who just needs to get it out. They're going to jump around to release some of the energy to become more stable in the sense that they calm down, hopefully. Then we get the elements that are entirely radioactive. These are elements 84 and the rest, from 84 to the end of the elements that we know of on the periodic table. The reason why they're radioactive is because there's so many protons and neutrons crowded together in the nuclei that there are strong repulsions between them. This causes it to be unstable. Think of it like two groups of people that absolutely despise each other trapped in a room. They're going to want to fight, and therefore they make the environment unstable. Now, there's a few types of radiation, and as a reminder, you can't taste, feel, or smell radiation, but I will get more into how you can possibly tell if you have radiation poisoning in a later episode. One type of radiation is alpha particles. These contain 2 protons and 2 neutrons. Because they have 2 protons, the alpha particle has a charge of positive 2. And these aren't that deadly, and I'll get more into that a little bit later in this episode, as you just have to get through the other 2 first. Then we have beta particles. They have an increase of energy compared to the alpha particle and are just an electron, which means they have a charge of -1 and a mass of 0. Beta particles are represented by the Greek letter beta, or the symbol for the electron. They're produced when an unstable nuclei has a neutron turn into a proton. Next is gamma rays, which you've probably heard of from Marvel or something else. Gamma rays are high-energy radiation that are similar to X-rays. They are released as an unstable nuclei that undergoes rearrangements of its particles to get more stable and have a lower energy nucleus. Gamma rays are shown with the Greek letter for gamma, which looks like a Y. Because of gamma ray energy, there is no mass or charge associated with the symbol. Now for protection. I know, you've probably been dying to hear about this. And this is where I'm going to explain why alpha particles aren't super deadly and you don't need to be too worried about them. Alpha particles only travel about 1 centimeter in the air before hitting another molecule and turning into helium. This means that your skin and clothes are good enough. Beta particles you need to be a bit more worried about, so you can wear heavy clothing like lab coats and gloves. Gamma rays are something you need to be a bit more worried about, and you need lead and concrete. This is probably why when you get an X-ray you see the nurses stand behind a concrete or lead wall, because they are constantly getting X-rays, radiation, whereas you're only getting it once, so they need more protection than you do, and you should be fine. Again, more about that in a later episode. But that's really all the introduction to radiation, and I'll see you next time. Thank you so much for listening. I really hope this helped, and thank you so much. I really appreciate you listening to this. Be sure to leave a comment below and let me know how I can improve, and to check out my store. Until next time, Emma equals MC squared.